Hello, in this video and in the next video, we will learn about the effects of temperature on the states of matter. When I say effects of temperature on the state of matter, I intend to tell you or I intend to inform you what happens when we add heat energy to a matter or remove heat energy from some state of matter. So first thing that we need to know or we should understand is that all atoms have energy in them. Some atoms have more energy in them, some atoms have less energy in them. Let us take an example of a hot glass of milk. In a hot glass of milk, in a hot glass of milk, there are heated atoms of milk. So let us say these are atoms or the molecules inside the glass of milk. Because they are hot, they have more energy, and when the hot glass of milk cools down, when this glass of milk cools down, the atoms have lesser energy. So atoms always have energy in them. They may have more energy or they may have less energy. Ice has very little energy, whereas boiling water has very high amounts of energy in them. The second point that I want you to know is that atoms are always in motion. They are never stationary. Now, when you are looking at the wall in front of you, it may look pretty stationary. We cannot see atoms. But if you could see atoms, the atoms would be in motion. But because the wall is a solid material, it's a solid state of matter, the atoms do not have much space to move around and they are vibrating. Let me show you this by using a simulation, and here it is. Now, first of all, let me explain what this simulation is about. I have a big giant container here, inside of which I've got molecules of water. Now, what is the difference between a molecule and an atom is something that we'll come to in our future classes. But at the moment, for simplicity, consider them as different atoms that are making up water. Now, we have water molecules in them made up of atoms, and here I have got a burner. I can heat these atoms or cool them down, right? So, these are this is water basically. So I've got solid state, the liquid state, and the gaseous state here, and I've got atoms and molecules here. So I've chosen water for this particular simulation. Now, what were we talking about? We were talking about that atoms are always in motion. And let us go back to our simulation and see how are atoms in motion. So this is the solid state. In the solid state, and this is water out here, it's a solid state. Basically, I'm showing you ice, the atoms present in ice. Can you see that they are in motion? But because there is very limited amount of space that they have, they are simply vibrating very close to each other. Now, how are water molecules found in the liquid state? And this is how they are found. Now you can see that they have comparatively little more space and they are slightly free to move around slightly. And let us look at gases. When I look at gases, you see the amount of space that these molecules have. And when the water is in its gaseous state, when it is in the form of steam, or the clouds that you see is the gaseous state of water, you see there is a lot of space between them and they are always in motion. So what have we learned so far? That in solids also the particles or the atoms are in motion. In liquids there is slightly greater amount of motion because of greater space, and in gases there is a lot of space and thus a lot of motion of atoms or particles of the matter exist. So these are the 2 points that we've done in this particular video. All atoms have energy in them and atoms are always in motion. I will see you in the next video where we will learn what happens when we add heat energy or when we remove heat energy from any state of matter.